Very good morning to all dear students. So I extend a warm welcome to all my dear learners of January 2025 batch. Okay. So students, myself, Dr. Tanupreet Sabharwal. So I am your course instructor for this course. That means your computer science and IT course. Now, learners, let me give you a little bit introduction about myself. So, students, I am working as an associate professor at Amity University Online, and but of course in your department, that is the IT department. And my PhD specialization is in artificial intelligence and machine learning. So, students, throughout your this semester, I am going to take two subjects. Okay, so the first subject is in front of you. That means computer science and information technology. And the second subject, which I'm going to take in this semester, is human computer interaction. Okay. So many of you were coming to the July 2024 batch class also. But now, from today onwards, we are going to start our classes from the January 2025 batch. Okay. So a lot of good mornings are coming, and I am going through all the good mornings. So students, before I start with the your session for today, see, I want to make some announcements. Now let's restrict this class to be an academic class. Okay. So we are going to refrain and we are going to discuss the things related to our academics. Now, since you know that your particular course is having 5 modules, okay? So for each particular module, you will be having a class. Now, what should be your ultimate target, that you have to take the best out of these sessions? Okay, so how can you take the best out of these sessions is that you have to, do a little bit pre-reading before you come to the class. So now let's start with this session. And my earnest request to all of you is that let's stick to the academic part in our live sessions. Okay, so learners, this particular course of yours is computer science and information technology. Okay, so here we are going to get a introductory concept as to what is computers, what is operating system, then what is internet. Now, I totally understand that many of you are from computer science background and many of you are not from computer science or mathematical background. But now, we have to understand the things. So, this particular course has been designed that way. So, how we are going to maintain the decorum, how we are going to maintain the discipline in the class, that we have to be patient with the things. Because, I will be giving you some questions, I will be giving you some, brain teasers so that you have to think. So if you know the answer and others are still trying, but we have to be a little bit patient. So these are some simple rules and regulations of my class so that the learners can benefit, in a very fruitful manner, whatever I am teaching you. So I guess now, without wasting time, let's start with our class, right? And students, one more thing I would like to tell you, that this is the phase one of the class. Okay. So in the phase one of the class, I'm going to discuss the theoretical aspects with you so that you understand this subject hypothetically. But in the phase two of the sessions, now in each phase, you're going to get 6 sessions. That means for each module, there is one session, and then there would be a revision session of all the modules. Now, how I have strategized your course planning for this semester, that in the phase one, we'll discuss the hypothetical concepts, the what, why, and how concepts. And in the phase two, we are going to discuss the practical scenarios, the use cases, and also we are going to, practice some questions based on our examinations. Okay, so I guess we are sorted, and now let us begin. And one more thing, please try to join the class in time. I wait for 2 to 3 minutes or 4 minutes, and then after that, I start with my class. So, students, let us start with our class. Now, at the end of this class, you will be able to understand the following. First of all, basically, what is a computer? This is an electronic device capable of sending an input, processing, and then output. And then we are also going to discuss in today's class the evolution of computers, then how you can differentiate, you can say, between the various generation of computers, what are the various components, And then how do you classify between the different memories? For example, what is primary memory? What is secondary memory? Okay. So this is going to be your learning objectives for today's class. Now, again, there is one more thing which I would like to share with you, that all the recordings will be available to you. Okay. Now, see, it takes a day time, or you can say 2 days for the recordings to reflect on your portal, right? But then again, um, you have to be a little bit patient about the recordings. You get them in a day or two, right? Now let's start. So students, if you want, you can just run yourselves through you can say the learning objectives. That means whatever content we are going to cover. So this is the understanding which you are going to develop by today's session. Okay. So now, and if you have any doubt, then see, I prefer taking up doubts when you listen to my entire lecture. So the last 10 minutes of the session we can put up as a doubt session. Now, see, obviously this is the first class, so you won't be having doubts right now. But again, if you are coming to my class next week or whenever is the next class schedule, so obviously you would be having some doubts. So those doubts you can put it in the chat box. Now, I guess the things are clear. Now, see, why am I telling you all things? Because, this will felicitate things between the teacher and the student. Okay. So, because, we have to set up that frequency of learning. See, I have to set up that frequency of teaching, and you have to set up that frequency of learning. So I hope, see, these are some trusted measures, which I usually follow up in an online class so that you understand the concepts in a more better, in a more synchronized manner. So now going ahead, okay? So students, see, I told you that this particular module of yours is basically an introductory module. Do you understand? That means what is a computer, what is the history of computers, and then what are the different generation of computers. Now, learners, if I have to give you, right? Okay, now one thing I want to ask you, am I totally audible? And is my speaking frequency clear? That means, am I totally, you can hear me properly? Okay, thank you, Vaibhav and Pranjal, for confirming. Right. Now, see, now let's understand what is a computer. See, we all know that computer is basically an electronic device, or you can say without these tech gadgets, it's really very difficult for us to survive in this tech savvy, in this cyber savvy world. Okay, now here, if I talk about a computer as a layman, right? Now, this is basically, you can say, an electronic device that is processing your data, and it is performing a variety of tasks. Now, obviously, this variety of task is performed very efficiently. This variety of task is performed very accurately. Now, here we have to understand that computers are basically, you can say, a very integral part of the modern society, because it's impacting our culture, it's impacting our life, you can say our lifestyle, or it's impacting our communication. Now, whether it's your entertainment, whether it's your education sector, the business sector, or any sort of research, computers are used everywhere. So students, what would be a layman's definition to computer? So this is basically, you can say, an electronic device, which is having an input, then, it is having a processor, and then it is having an output. And but of course, it is also having storage. Okay. Now, this is something we have to understand. Now, coming to the next slide. Let's understand what are the different parts of a computer, right? Now, see what you can see here, that the different parts of the computer you can see. Now, these are some parts which we can segregate as the input devices and the output devices. So the very first question which can come in your examinations. Now, let me tell you that in your exams, okay, you are going to get descriptive questions also, and you are going to get the MCQs also. Now you have to prepare yourselves for the MCQs and for the descriptive questions also. So that is a later part of discussion, but right now let's focus on the content. Now, for example, if you get a question that which of the following devices is an input device, which of the following devices is an output device? Okay, now here you can see, and I now have a short activity for you. Now, what you have to do is that in the chat box, you see, many of the students are putting their responses in the question and answer box. Okay. So you have to put your responses in the chat box. Yes, Vikas, this is the first class for BCA first semester, January 2025 batch. Okay. See, that is why I urge my students to come to the live classes on time, because you miss a lot of announcements. See, what happens is that it's totally okay that you can go through a recorded session, but in a live session, you can always, put up your queries. You can ask your doubts to the faculty. So, I totally encourage and I want all of you to come to the live classes. Okay. Okay. Now, let's do a short activity. Now, learners, see, we have to make this class engaging so that, it's interactive and we are finding interest at both sides. So during my class, I am going to engage you into activities, into quizzes. Now, what is the first activity for the day? That you have to tell me how many of the devices which you can see in this figure are input devices and how many of them are output devices. Now, do you understand what is an input device? Okay, how many of you understand? Can you just raise your hands? Okay, see, I already got a response from Deepti that she has given me the answer for the input device and the output device. Okay, so will you like to try this? How many of you want to try? Okay, okay, come on. Okay, so students are trying. Right. Now, what is our what we are supposed to do? From this figure, you are required to put in the names of the input devices and put in the names of the output devices. Okay, come on. I give you a minute to just go through it. Okay, so I'm getting varied responses. See, learners, module 1 of your course of computer science and information technology is not that technical. It's not that you can say tough. It is a very general purpose module which has been designed. Okay, so obviously I know the things which you know that only I'm going to ask you in the class. Okay, so as Yogeshwar is saying that input device is a scanner, it's a keyboard, it's a mouse. And Vaibhav is saying that output device is a speaker, printer, and a monitor. Good. And I can get varied responses from Ishwinder also. A lot of students are putting the responses. Sana, you have not put the answer here, okay? And Arnab has also given me the response. So this is, good that you are always, see, now we have to understand. Now, what is the input? That means what sort of instructions you are given. For example, when you are entering the data into a computer, right? So this is done with the help of, you can say, a keyboard, or you are giving these instructions. Now, when you get that output displayed on a screen, for example, that is your outcome of that particular data which you have entered. So that is basically an output device. So again, this was very simple. And again, there are many students who are putting in the Q&A. So I want you guys to put your responses in the chat box. Okay? Come on. Now, I guess this was very simple, and many of you gave me the correct response. And I'm really happy that, this awareness about a computer system is already there with my IT students. Okay. Now, moving ahead, just a minute. Okay. Now, students, the most important thing today is data. How many of you agree with me that today, we are dealing with a lot of data? And how many of you have heard about the term big data? How many of you have heard about the term big data? Okay. What is this big data concept? Or, we are nowadays talking about a lot of data concept, whether it's the variety of the data, the velocity of the data, or you can say the different formations of the data. See, data basically means when we are requiring high speeds for processing, because, when we have to process this large volume of data, then, the accuracy, the complexity. Now, here you have to understand the difference between data and information. Okay. This is students, data can be anything. It can be raw data. And information can be something, a sort of facts, a sort of figures. That means factual information. Now, for example, before coming to this class, for example, you have gone through your SLM, you have gone through some YouTube sources, but that was data for you. But now, when you attend a class with an expert or with your faculty, then you understand the factual concepts, you understand the informative concepts. Now, this is something which we need to understand. Now, obviously, data can be in the form of symbols, it can be in the form of words, it can be in the form of audio, or it can be in the form of a video also, right? So here, information is something that is making sense. Now, see, whatever I am talking, this is in context to your course. This is in context to your module 1 of your course, Computer Science and IT. Now, this is something information which I am providing you with respect to your course. Do you understand the difference between data and information? Yeah. So now we have to understand, for instance, data is something that can be raw. It can be in a more technical sense. It can be, you can say, unstructured. But now when I'm talking about information, so information is something, learners, that is structured, that's polished, and you can say the exact facts and figures are being presented to draw some inferences. So this is basically the difference. Now, students, the next set of question is ready for you. What is the difference between, you can say, data and information? Okay, so this is the next set of question which is ready for you. Difference between data and information. So, in till now, anyone is having any doubt, whatever I have discussed? If you are having any doubt in the part which I have discussed till now, then you can please put it in the chat box. And if not, then I'll continue and we'll take up the doubts in the last part of the session. Okay, so I'll just go through the chat. Okay, so thank you, Sagar, for your confirmation. Okay, now let's talk something about I'm sorry, about as to why a computer is so powerful. Now, students, obviously, in this era of AI, in this era of emerging tech, where the computers, or you can say nowadays we will not call it a computer, but we'll call it a supercomputer, where it is obviously performing better than the human being. But here we have to understand that what are the factors, what are the characteristics, um, which are making the computers so powerful, or they are more efficient than the human beings. See, students, you have to understand that a computer is not subject to fatigue, but a human being is subjected to fatigue, right? And then obviously the speed, the accuracy, because nowadays we are using new computational resources. Now, with the help of this powerful computers, with the help of such powerful computational resources, we are able to process the large volume of information. And obviously, we can connect whatever can be connected in this world. So these are some facts, these are some figures which are making, um, you can say, the computer so powerful. Now, Sofian is asking me to explain the difference between input and output devices. So basically, an example of an input device can be a keyboard, a mouse, and an output device can be your, for instance, your monitor, okay, your screen. So that can be an example of your output device. Now coming to the next slide. Now, students, here we have to understand that how does the computer know that what has to be done? So, learners, this you have to understand that whatever programming languages are there, for example, if it's R, if it's Python, or it's C, so all these are high-level programming languages. But your computer is only understanding the machine language, or you can say a language which is a formation of ones and zeros. How many of you were knowing this, that the computer doesn't understand your high-level programming languages? For example, the computer doesn't understand Python, it doesn't understand the C. Whatever code you are writing, do you understand? It is converted to your machine language. And that machine language is basically a combination of ones and zeros, right? This is a combination of ones and zeros. So now here we have to understand that the computer system is basically a set of hardware, right? So whatever software we are providing, whatever code we are writing, so that is a form of instruction. So that particular instruction is a high level language, and that is converted into a language which is known as a machine language, because the hardware ultimately understands only a combination of ones and zeros, but it's not possible for the human being to understand such lengthy combination of ones and zeros. Okay, so this is a very important inference which everybody should pay attention. So if a question comes, how does a computer know what to do? Obviously, we are the users, the end users, the consumers are providing the softwares, they are providing the computer programs, which are converted into machine language, which is a combination of ones and zeros. And that is why they understand. Okay. Yes, R.S. Prasad, you are correct that we need compilers, right? Yes, you are correct. Okay. Reshma, you don't have to join this class. You are a July 2024 batch student, and this class is for January 2025. Okay. So please concentrate on your exams, Reshma. This class is not for you. This is for your juniors. Okay, so now if students of July 2024 have joined this class, you are not supposed to join. Please focus on your examinations, right? And students of only January 2025 batch should be there, because your exam is already done for this course. Okay, coming to the parts of a computer. Now, there was one student, Sufyan, was asking me about the input and the output devices of a computer. So, Sufyan, now you pay attention, because here you will be able to understand that, first of all, what are the various components, what are the various parts which are associated with the computer, and what is the functionality. Now, learners, I guess this particular diagram is self-informative, and it is telling us that how the computer system is working. So it is having a set of input devices, and then it is having a set of output devices, storage devices, and then above all is your CPU. Now here, learners, the CPU is known as the brain of the computer, because whatever inputs we are providing, that are being processed logically, and then the output is being reflected on your output devices, and the results are stored in the memory. Okay. So this is basically, you can say, if you get a question, what are the different components, or you can say, what are, you can say, the various parts of a computer. Okay, so Nayab, basically, ALU is also a component of the CPU only, and ALU is basically arithmetic and logic unit, and it is responsible for performing your arithmetic and logical operations. For example, if it's arithmetic, for example, your addition, subtraction, multiplication, if it's logical, for example, the logic gates, the AND gate, the OR gate, that means the logical operations. Okay. So all the arithmetic operations, all the arithmetic calculations, the logical operations are being taken care by the arithmetic and logical unit. Okay. Is this clear, students? Then obviously you are having a set of storage devices, output devices. Now coming to the next slide. Now let's discuss into detail your input devices. Now see, there are a lot of input devices, but let's now focus on the keyboard and the mouse, and this is very simple. Now I'll just take you quickly through the keyboard and the mouse, because this everybody knows. And then again, we can discuss many things ahead of your session in this course. Okay. So this everybody knows that we are using the keyboard to pass on the instructions to the processor. And then obviously you are using a mouse. Okay. So here you can just go through the functionality of the keyboard and the mouse. So students, this is something that's very basic, that's very, very fundamental. So I'm not going to take much of your time into it, because there are various other things to be discussed. So I guess this is simple. We can proceed. Okay. Yeah, I guess, and we can proceed with this. I'm getting no inferences. Okay. Okay. So now I got your response. Thank you. Okay. So going ahead. Now comes the CPU. Now, students, this is something that's important. Okay. Now here you might have gone through or you might have seen various chips. For example, Intel, Pentium, Intel 4, Pentium 4. So what are these? These are your CPUs. These are your chips, integrated circuits. Now, learners, basically the CPU, it interprets, it understands your instructions, and it performs whatever functionality. For example, if it's an arithmetic functionality or it's a logical functionality. And here we call the CPU as the brain of your computer. Because students, here the CPU is basically responsible. Do you understand? CPU is responsible for doing your calculations. Now, for example, if I have to discuss the various generation of computers. Now, how many of you remember or how many of you have heard that that earlier, there were computers and the size of the computer was as big of a room. So, the earlier computers were also having the CPU, and it was having a control unit also, and it was having an arithmetic and logic unit also. Now, obviously, in a CPU, the control unit coordinates, it controls the activities of other components. Now, at that time also, when the computer was that big as a room, the control unit had the same functionality, but nowadays the features are enhanced. Similarly, the CPU is having your ALU also. That means your arithmetic and logical unit also. Now here it's capable, or you can say it performs the arithmetic operations, it performs the logical operations. Okay, so now if I have to talk to you about the various generation of computers, so students, basically the computers started, coming into the market between the 1940s to the 1950s. And earlier, we used to have vacuum tube based computers, and they were not portable and they were very heavy. And the name of the first computer was ENIAC. Okay. The name of the first computer was ENIAC. So Shivam, basically arithmetic and logical operations basically mean arithmetic operations means your mathematical calculations, and logical you can say the logic gates. So see, if you do not know the logic gates, don't worry. In our second unit, we are going to understand the logic gates, the AND gate, the OR gate. Okay. Yes, Sagar, you are correct. We are having uh, you can say broadly 5 generation of computers. Okay. Now see, let me talk to you about the generation of computers with respect to the CPU concept. Now the first generation was between the 1940s. It was between the 1950s. And now what you have to learn in the generation of computers, and all of this is mentioned in the SLM. Okay. So what you have to do in the generation of the computers, for example, what was their time period? And for example, they were vacuum tube based. Now came the second generation of the computers. Then again, there is a plus 10 years. That means 1950s to 1960s. Now they were transistor based and they were smaller in size. Now see, you have to understand, students, as we are going ahead of technology, so the size of the electronic circuit is decreasing. How many of you agree with me that as we are heading into technology, the size of the electronic circuits is decreasing or increasing? How many of you agree with me? Okay. Now this you have to understand. See, whether it's your storage, whether it's your memory, whether it's your input-output device, or whether it's your CPU, which contains your control unit, or it contains your ALU. The first generation of the computers was big. Okay, and they were based on vacuum tubes. Then came the second generation of the computers. The size became a little bit smaller, but they were transistor based. Then again, a plus 10 years for the third generation of computers. Now the third generation of the computers is between you can say 1960s to 70s. Now they were IC based. Now, how many of you have seen your mobile chips? That means your SIM cards. How many of you have seen the SIM cards? Now, students, that is your, you can say, integrated circuit. Okay. So whatever SIM card you have seen, that is an integrated circuit. So integrated circuit came into existence with the third generation of the computers. Now, you just imagine the size of your SIM card nowadays, and it was earlier. So as we are going ahead into technology, we are following the Moore's law. That means after every 18 months, The size of the electronic circuit is reducing, but its complexity, or you can say its features, are increasing. Then students came your fourth generation computers, again a plus 10 years, 1970s to 1980s. Now they were microprocessor based. Now what is a microprocessor? That this is something you can say a multi-purpose CPU, an enhanced CPU with a, you can say enhanced performance and capability. Then came your fifth generation computers. That means your AI-based computers. That means from 1980s, from 1990s to till date. Now you are having your supercomputers also. Now students, these computers are AI-based. These computers are using parallel algorithms. So now what you are supposed to do that with respect to these, you can say learners, these components of your computers, okay, you have to understand, first of all, you should be well versed what type of generation, what is the year, and then what is the device, and what is the pros and cons. So I am putting a small explanation for you in the chat box, everyone. Okay, so just go through it. So whatever I have mentioned here, this is what you are required, and you can expect questions from the generation of computers in your examinations, both MCQ and a descriptive question. Okay, so I have just shared it with you. Right. Now, again, let's discuss the computer memory. Now, students, whenever I'm talking about memory, so memory is something that is capable of storage. Now, in a computer, we are having two types of memory. One is the primary memory, and the other one is the secondary memory. Now, students, if I tell you about RAM or ROM, so this is basically your primary memory. And again, in RAM and ROM, one very apt question which you can get is which is volatile and which is non-volatile. Now, do you understand what is volatile and what is non-volatile? Now, see, okay, how many of you know what is volatile and non-volatile? Okay, so Hemant is saying RAM is volatile and ROM is non-volatile. Okay. Okay, Dibyajit is also saying, okay, who knows what is volatile and non-volatile? Please put it in the chat box. Let me see. Because these are some fundamental concepts. If you don't know, otherwise, I'm going to tell you. Okay. See, students, you have to understand one thing that what happens is that, for example, your power supply is intact. Okay. What is volatile? Volatile means it is going to evaporate. It is going to vanish. So similarly is the case with data. Now, ROM is non-volatile. Okay, so ROM is non-volatile. That is means that whether the power supply is on or not, your data is not going to go anywhere. But RAM is volatile. That means when there is a power cut, you switch off the power supply, your data is going to vanish. So this is basically the explanation for volatile and non-volatile. Okay. So this is something which you should be well prepared for your examination purpose also. What is primary memory? So primary memory, RAM, ROM. Secondary memory is basically also known as auxiliary memory. For example, your USBs, hard disks. So that is your secondary memory. ROM is non-volatile. Why? Because even the power supply is not on, the data is there intact. It's not, see, volatile you can just remember as evaporation. The data is not evaporating. It's not going off. Okay. So clear? One student was asking about volatile and non-volatile. Now, obviously, students, we have to understand one more thing that I told you that the computers are only understanding one language, that is the machine language, a combination of ones and zeros. So here we need to understand that this particular logic of binary, or you can say of Boolean, is that, for example, if the light is on, that means it's a true condition, it's one condition. And if it's the light is off, then it's a false condition, it's a zero condition. So this is how students, the information is stored in a computer. And this is pretty simple, I guess. Okay, yeah, it's binary system. So, in our module 2, we are going to discuss all this binary system, how to work with Boolean algebra. So all this we are going to discuss. Okay. Okay. So now, okay, students, ASCII is basically known as American Standard Code for Information Interchange. And let me tell you, see, if it's a single one or it's a single zero, so we call it a bit. But A combination of 8 bits is known as a byte. What do we call it? Byte. So you should be well aware with these small inferences. Yes, assembly language or machine language is known as low-level language. Yes, Nayab, you are correct. Yes, Sagar, binary basically means either it's a 0 or it's a 1. That means a true or a false. Okay. So now coming to your, see, if you want, you can just go through these facts and figures that in a, you can say in a general or in a normal configuration, the RAM configuration is 1024 bytes. That means 2 raised power of 10. Okay. And so this is the configuration which I'm showing you, not for a supercomputer. See, obviously, if it's a supercomputer, then it would be having a NVIDIA A100, the latest one, which we are having, the NVIDIA A100 series server. So these are the configurations which I'm showing you for general computers. So this is just a factual figure which I'm presenting so that you understand that if it's a normal RAM, for example, if it's 8 GB, so how do we basically calculate it in megabytes or in bytes? Okay. So now let me show you the, okay, now I guess this we have already discussed, the output devices. It can be your monitor screen, okay? Then let's discuss the storage devices, and specifically learners, we are going to discuss the secondary or the auxiliary storage. Now see, you can get a question into examination. By the name of secondary storage, or you can get a question into examination by the name of auxiliary storage. So it is one and the same thing. So if it's primary storage they're asking you, then it should be a RAM or ROM. But if they're asking you about secondary storage, then it can be a hard disk. See, nowadays actually we are not using all these secondary auxiliary storage devices. But now why we are teaching you? Because you should know from where you have evolved. You understand? You should know from where you have come up, from where you have evolved. So earlier days, we were using hard disks. Earlier days, we were using, you can say, magnetic disks, CDs, compact disks, right? So all this is, see, I'll not say that we are not totally, we have eliminated, but the usage is really very less. Yes, R.S. Prasad, you are correct. We were using the floppy disks also. And nowadays, obviously, we are using SSDs. Okay, nowadays, what are we using for storage? It's a sort of virtual storage. Who can give me the answer? Nowadays, what are we using? Come on. Again, a brain teaser for you. Nowadays, what are we using? Come on, tell me. Okay. Okay. What about the rest of you? So nowadays we are using the cloud storage, the Google, you can say the simplest one being the Google Cloud. Aren't we using it? Yeah, we are using the SD cards. Yeah, we are using SSD for storing data in the cloud system. So, a broader term can be the cloud storage. Now, but still students, we should know what were the earlier mechanisms, or in your generation, it can be what were the traditional approaches of storage. So in your SLM, you are going to find all these things. Okay. Come on. Then again, for the media storage, for example, for your mobile storage, we used to use the flash memory cards or the USB flash cards, your USB drives. So all this was used earlier. See, nowadays also it is, yes, pen drives also. Nowadays also it is used, but the usage is less. Because see, obviously, why to maintain this sort of hardware? Because obviously with the hardware, there is a wear and tear. So now we have switched to the cloud. Now, see, here in my class, I'm not supposed to discuss too much cloud with you, but still, I just can't help myself without discussing the latest technologies in class. Okay. So now taking you ahead. Now, students, let's come to a very important topic. So now we are almost done, you can say, with the parts of the computer, then you can say with the different generation of the computers, then what are the different components? For example, input, output, and also we have discussed a lot of applications also of the computer. Now, for example, if I have to talk about the application, so the computers are used in the education industry. They're used for learning, they're used for research, entertainment, gaming, multimedia production, broadcasting, data analysis, engineering, science, medical. So these are a lot of applications which we have already learned. Then we have also understood that with the help of with the advancement of computers, with the advancement of your different generations, day by day the size is reducing, and we are able to tackle the large volume of the data. And also, we are designing computers which are not dissipating a lot of heat. Do you understand? Earlier, the computers would used to dissipate. You understand? Let me explain you it in a very simple manner. This means that there was a lot of heat generated. Now, this heat generation is also reduced. So this we are going to understand in a couple of further sessions as to how this advancement is possible. Okay, so now let me discuss a very important part with you, that in a computer, basically there are two types of softwares. So students, one is the operating system and the one is the application software. Now, see, operating system everybody knows. For example, if it can be Windows, it can be Mac, it can be Linux. So, what is an operating system? That means a software that is developing an interaction between the user and the computer. Now, see, learners try to understand that operating system is only responsible to maintain that communication between the hardware, the black box, and you. Now, you understand English, you understand the high level language. Now, what is the machine understanding? The machine is understanding the assembly language. The machine is understanding the machine language. For example, the ones and zeros. Do you understand a large combination of ones and zeros? No. So, who's responsible to convert this data, to facilitate this interaction between the end user and the computer? Now, students, who is the end user? The end user is me, the end user is you, right? So this is basically the operating system. Now, I guess you are well versed with the operating systems. Now, see, students, nowadays, the operating systems which we are working, they are basically GUI based. That means the graphical user interface. And in your module, we are having a separate module on operating systems. Okay, so there I will be taking up your practical also for the OS, and as to how you can understand the difference between a traditional operating system, that is a DOS, a disk operating system, and your latest operating systems, that are GUI, graphical user interfaces. So nowadays we are using graphical user interfaces, for example Mac, Apple OS, then Windows, Linux. So all these are GUI based. Okay, so I guess that's pretty clear. Now coming to your application softwares. Now see, application softwares means that means your MS Word, Excel, PowerPoint, right? Now here, these application softwares is basically, you can say, application specific. Obviously, you cannot make a PPT on MS Word. Then you cannot write too much text into a PPT, right? So they are application specific. A certain application is associated with it. So again, you can get the difference between application software and an OS, operating system software. And then you can also again get it in an MCQ. So you should be well versed. See, when you come to a live class, you also get, you keep on asking when your exams come, that what are the important questions. So if you are attending a live class, you are very well versed with the concepts and you understand. Do you understand that in which particular topic, what amount of attention is to be paid and what amount of things are to be taken into consideration? Is it clear? The difference between the operating system software and the application software. Now, for example, let me take you through, for example, this is your, what is word processing? Application software or not? Yeah, Sana, you can include it. Okay, so this is one inference, right? Then coming to your electronic spreadsheets. Now, see, electronic spreadsheets, for example, your generation, you can understand it as, for example, your Excel, Google Excel sheets, Google Docs. So this can be your application specific interfaces. Okay. Then coming to your database softwares, for example, your SQL, MongoDB these days. So this can be. Now, I have tried to incorporate the traditional things in the PPT because your generation is not aware about it. But still, students, this is the very first module and we should know from where we've evolved, right? So this is really very important for us to know from where we've evolved. Okay. Now, coming to the presentation graphics, for example, your PPTs. Okay. So this is all an examples. Yeah, Raj, you are correct. The Google Docs also. So students, this is all an example you can say for your application softwares. Okay. Okay. So Sagar is having a question. I about RAM is okay, so Sagar, see, both RAM and ROM are your primary memories, okay? And secondary or auxiliary storage, I'll show you here. Don't get confused. So starting from the hard disks, this is your secondary storage. That means when you are done with your, for example, see, there is a large amount of data which we are not, you can say, focusing, which we are not using regularly. So obviously we can put it into your secondary storage device. Okay. Now, students, if you are having any doubts related to academics, you can put it here. Though I was trying to answer it throughout the session. Yeah, Raj, SQL also we are using. But in this first class, just don't get into too much technicalities because I am having various students who are not from the computer science, from the mathematical background. Okay. So what you can do is that if you want to ask me something that's ahead. Okay, if you want to ask me something that's ahead of your course, or if you feel there is any point that's not understandable, then you can always write to your faculty or ask your professor. Okay, so one student is asking about the difference between data and information. See, data is something that can be raw without making any sense, and information is always making sense. Okay, see, you don't, yeah, you can put your queries on ask your professor. So Siddharth, RAM is random access memory and ROM is read-only memory. Okay. Yeah. Sana, yes. Your answer is, the answer to your question is yes. Now, students, today again we are having our next class of human-computer interaction, and that class is most probably at 12 today. Okay, please join the class on time. And now I guess there are no more further questions, and I will be leaving because I am having a next class at 10. Okay, so basically it is converted with the help of a compiler. Okay, so there is one student who's asking me this Debo Lina. Okay, so this is converted with the help of a compiler. Okay, so GUI is basically graphical user interface. Okay, so one student is asking me about GUI. So this is graphical user interface. See, students, not to worry if you feel that any of the thing is being left out. So you can always write to your faculty on ask your professor. Okay. Okay. So Bappa Mamdal is asking. So RAM is basically your random access memory and ROM is your read-only memory. ROM is non-volatile and RAM is volatile. Okay. Okay, so Siddharth, don't worry about the syllabus. All the syllabus will be discussed with you as and when the sessions are going on. So today we have discussed, and this was the very first class with you people. So we are going to discuss all the syllabus. So whatever is being taught to you in this first class, that is your syllabus for module 1. Okay, so thank you students for joining the class. And from next time, I want you guys to be on time. And again, Krish is asking me the same thing. Krish, GUI is graphical user interface. Okay, thank you.